All right. Fantastic. Well, I couldn't be more excited to be at my 6th Meridian. I've been building Stellar apps for 10 years now. Wow. And I've been on this kind of ulterior motives, trying to get Stellar to add Soroban smart contracts. Now we're adding in some functionality to make it much, much easier for users, because I want to build a crypto game, but I don't want it to feel like crypto. I want it to be really easy, really simple. So it's a very long con that's taken me 10 years to get to where we are today. And it's going to be a demo. I think in applications and actually being able to see what's going on, but I don't trust conference Wi-Fi to hold up for me. But I do trust my internet from 2 weeks ago. So I recorded a bunch of demos that are going to walk through exactly what the Passkeys are. And it's really not just Passkeys, it's smart wallets in general. These aren't something that are new, but there's a lot of innovation that's happening because of the way that Soroban has been built. So I want to take some time and kind of open up your mind to what's possible thanks to Soroban, thanks to, I don't know if any of you have heard of check auth or the auth framework that's built into Soroban, but it enables some really incredible user experiences. We talk a lot about developer stuff, but I'm really interested in people not feeling terrible when they are using Web3. So I'm going to start getting into that. First, we're going to walk through the demo, and then we'll walk through the code.
What we've got here is a nice application that's going to allow us to do some math on the blockchain. We're going to go ahead and sign up. And you'll notice there are no pop-ups that we're accustomed to. All right, I've got all my different wallets, traditional Web3 wallets. But that's not the future. The future is Passkeys. So I'm just going to scan with my fingerprint to create myself a brand new smart wallet on the Stellar blockchain. That will throw off to the blockchain and create me a brand new smart wallet. Fantastic. Well, we've got our super awesome do math application here. We can do some math, the core of all math, addition. That'll shoot off to the blockchain. We got a smart contract that gets invoked. You sign it, with that nice fingerprint scanner. So much better than passkeys and pop-ups and passphrases and nonsense. You'll also notice there's no XLM involved. That's being paid by another service called Launchtube, which, if you're familiar with the Ethereum space, you might have heard of Paymasters. We've got Launchtube, very similar. So didn't have to acquire any XLM in order to perform these mathematical functions, these contract invocations. So that's all well and good. That's the future. But what about the future's future? That would be this next ability to add additional signers on top of this smart wallet. So rather than a smart wallet being directly tied to this passkey signing capability, really it's just a smart wallet that has multiple different types and numbers of signers on it. So we could sign with a classic Stellar account. So a passkey is this SecP256R1 signer, and the ed25519 is kind of the classic Stellar G address, if you will. So we'll go ahead and add that to our account as well. What's super cool about this is this key could very easily be passed around to other users of your account, even applications, right? You could consider maybe giving it some back-end service, and now they have access to use your account without needing to ask for your SecP256 passkey account. They can just use it and sign with it. So if we try and do math now with the ed25519, there's 0 pop-ups. It just does math, which is super handy because I've got a lot of math I want to do and don't want to have pop-ups coming up all the time. Now, the astute observer will notice this is a terrible thing to do because, well, now we've just given access to our entire account with this secret key, right? So if I go and I share this secret key over with some other user, back-end service, what have you, they can, of course, do math on my smart wallet. That's wonderful, but they can also steal all of my money by doing transfers. So that's not great. That's where the third signer type comes into play, where we've got our passkey signers. We've got our ed25519 classic G address signers, and now we've got this new future policies, which essentially allow us to add additional code checks that run when other signers are being used, whether those are Passkeys, G addresses, or even other policies. So this particular policy will ensure that the only thing that this ed25519 signer can do is math. It will not be able to do transfers anymore. So we'll attach that policy, scan for it, which attaches it to our smart wallet. And it attaches it to where it only affects the ed25519. So if we're back on our account over here now, and we go and try and transfer, it will fail because it's not allowed to do that because we attached a policy to that ed25519 that only allows it to do math. And this is incredible because now we can safely hand over access to our account, signing access to our account under very restrictive permissions, only a certain type of interaction. Completely composable. There are not standards that are limiting in what you can do. This is just a smart contract that's running behind the scenes, attached on top of, in this case, the ed25519. So no pop-ups, but also completely secure and safe because it's entirely restricted to only permitting this key to do math.
All right. So it's a stupid example, very simple. I hope you're doing more than just addition. But I like stupid examples because it opens up the opportunity for you to think about all the things that are possible now and all the things that you might want to do, particularly, again, for me, the idea of a back-end signer. So something like a subscription service that's so basic to payments now becomes immediately very simple, where you don't need to proxy off a small amount of money, you don't need to sign a bunch of transactions for some time in the future to be executed. You can attach a signer to your actual wallet, and the only thing they can do is whatever is according to that policy signer. So this amount at this interval, you can add logic to change from monthly to annual. It's all composable and completely safe because it's according to actual smart contract logic. But it's not another smart contract as a service, it's smart contract as authentication. So that's what the smart contract is, but interacting with those things, I don't know if anybody's ever tried to do Soroban auth, but it's not the simplest thing. And so I wanted there to be a very simple way to interact with this on the browser side. So that's where we start to get into the PassKey kit, really starting to look at client-side code. And I apologize for those in the back. The code is a little small. You might have to lean in, use your binoculars. You should be able to see it well enough, or you can just listen to the sultry sound of my voice.
Well, I know what you're thinking, Tyler. That all sounds well and good. But what does the code look like? It's probably horrendous, very convoluted and tricky to actually construct all of these things and use them. Well, it's not. We've built a really nice PassKey kit, which allows you to implement all of these different signers and interactions, policies, and whatnot very easily. So the code here in the demo application is written out kind of in the same order that it was used in that demo I just gave. We create a wallet initially, that being tied to the passkey. Doesn't have to start there, but it's a good place to start. Passkeys are amazing, kind of default signers for your wallet. The meat and potatoes, though, is this do math method where we're interacting with the passkey wallet. And we're doing things like sign and send. I have this contract do math. This is where the mathematics actually happen. And I have a TypeScript bindings library that I've generated for this do math function. And basically what's going on here is it's just adding two numbers together. It simulates that transaction. This is the TypeScript bindings assembled transaction that comes back. We get that. We pass it forward to the passkey wallet, and it will do a signing depending on the arguments that you pass. In this case, when it just does math, and it doesn't do math with the ed25519 signer, it just does it on the passkey, and then it sends it. This is going to the server, which is going to use that Launchtube service. So with something as simple as this right here, you are interacting with and submitting a Stellar transaction on the Soroban smart contract protocol with this PassKey kit, which is so simple. It's amazing. Okay, that's all well and good, but that's actually interactions. What about adding signers? That's probably tricky, right? No, it is not. There's a lot of flexibility here in how you want to do it, but it's been boiled down into its essential parts and given good typing so that it's quite easy to interact with. You've got your PassKey wallet. You've got different signers that you may want to add. So you may want to add a SecP256R1 or an ed25519 or a policy. And depending on which ones you have, they'll all have their own arguments. In my case, I'm going to pass it a public key. There's a limits. So this is where those restrictions come in. And then you can also decide if you want to store it as a temporary entry or a persistent entry. Temporary entries being much, much cheaper. And for things like, I don't know, session tokens, logins, or temporary keys you pass off to your friend while they're doing something with your wallet, it would be a good idea to put it in temporary. So that's a nice option. So that's our adding that 25519 signer that we just saw in the demo. But because we're not adding any restrictions or limits, it's allowed to do anything. So if we wanted to not do that and instead attach a policy to that, we're actually going to not use the policy because we're not using policy as a signer in this case. What we're doing is we're updating or attaching a policy to an existing signer or to this ed25519 signer. So we're basically just going to overwrite in the attach policy function. We're going to override the existing key, and instead of having a blank signer limits, we're going to set some limits that basically say there's a do math contract that you're allowed to call. But when you call it, when you call it with the ed25519 signer, you have to also call the do math policy. And that policy is the restriction that ensures that when do math contract is called, it has to adhere to whatever parameters. Basically, this contract, this do math policy contract, has to run successfully. So we add that signer, basically doing the exact same here, same thing that we did before, only now the map has restrictions, limits have been set. We sign that and send it. So even adding restrictions, policy restrictions to a key, very, very simple. The rest of this is all very vanilla, simple JavaScript type stuff. The main things to pay attention to are just how simple, when you're using the PassKey kit, it is to interact with these smart wallets and get things on chain and add these signing limits. Pretty awesome.
Could not agree more. All right, so the last obvious one is that's all looking good, but what about contracts? What do the actual policies look like?
At this point, you must be thinking, okay, so where's the catch? Where's the hard part of this Web3 future that you speak of and demonstrate? Maybe it's in the contracts, the policies, or the interactions. What weirdness or convolution must lurk beneath the surface? Well, there's not any of that. You've been lied to for 10 years. Web3 doesn't need to be yucky. It can be awesome. Here's the contract for do math. It just takes an A and a B and adds them together. But because we want to ensure that authorization is triggered on the smart wallet, we require auth from a source account. That's what actually triggers the PassKey signer that will pop up, or the ed25519 signer, or if I had added a policy as a signer versus just like a limit on the ed25519. This is what triggers that. What does the policy look like, though? Great question. Glad you asked. This is a policy. Really, really simple. Obviously, certain policies will be far more complex than just function name limitations. There'll be arguments that it will list. It'll have a list of who's allowed to interact with it. Policies are just smart contracts. They can be anything. But there's no like special code. I'm There is this hard code of policy __. That is what is hard coded to be called inside of the smart wallet when a policy is discovered, interacted with, and then it just forwards two arguments: the smart wallet address, the source, and then a vector of contexts. So whenever a authorization is triggered via checkauth in the smart wallet, it includes this list of contexts, which is essentially what all are we authorizing here? What smart contract invocations are being authorized in this particular single contract invocation? So it's just a list of those. You can then check those. They will include all of the contract context, which would be like the contract name that's being called. So if you're calling a Stellar Asset contract transfer, for example, the contract would this contract value would be the contract address, the function name would be transfer, and the args would be the from, to, and amount arguments. So you can check all of those things and ensure that they meet whatever set of parameters the policy requires in order to pass this contract invocation. In our case, it's just looking at that context and saying, hey, looks like somebody's trying to do some math. If they're not, everything else should not be allowed. So only in the very limited case that the function name is do math, everything else is going to fail. So policies by default, not a lot of fanciness going on here. You have a complete unfettered ability to do whatever you want that policy to do when the check is actually happening, which is, again, just insane. There's no special SEP that's required for every single policy. I envision a world in the future when there's like a policy app store where there's just every dApp has lots of different community-made policies, and like the developers of the protocol will have different policies in order to, again, give you the ability to restrict access to whatever dApp or whatever you're connected to or website or service. It's placing these obligations on top of whatever signing key you're trying to use so that you can give that key to a backend service like a cron task so it can run certain functions, but only those functions that pass the policy. So it adds a whole new incredible world of secure access to your wallets, so that you don't have to be there all of the time clicking sign the pop-up, or even in the case of web wallets with Passkeys, scan my fingerprint, scan my face again and again and again. That whole horrible world goes away without giving up any of the security and self-custody. You design these policies, they only permit exactly what you would have been looking at anyway, right? We kind of have this horrible expectation that users are going to be reviewing transactions. There's no world in which that future actually pans out. Users aren't going to do that. They're either going to get robbed or there's going to have to be something better, because users aren't going to review that stuff. So what's nice about this is it gives you the same security, except instead of a user having to understand it, community and developers and popularity, right? The same policy is being used many, many times. It's been audited. Instead of users all having to review the same thing, which hopefully is actually safe, but that one case where it's actually not safe because something was snuck in, you can't sneak anything in because the actual review, the policy itself, is a smart contract. Can't be altered, can't be changed. It has to always behave as the code. So that's an incredible future where you attach these types of code runs inside of authorization. Opens up so many interesting use cases that will improve users and developers' lives 100-fold from what we currently see in the Web3 ecosystem.
And so, to quote my favorite developer, npm install passkey kit. It's time to go and use this. I hope I've inspired you somewhat that it's a very interesting and exciting future for us with smart wallets. There's a lot of work that still needs to be done, a lot of decisions that need to be made, but I'm incredibly excited about this future. I can see from my Slido that there are quite a few questions. I'm not going to have time to answer those on stage, but I would really, really love to be able to talk with you. And we're going to have to do that afterwards. There's lots of good questions. And I mentioned the Launchtube. That launched pretty recently. And if you're interested in getting free tokens to submit transactions on mainnet, I would love to hand you a $100 Launchtube token. So come and ask me about that. I'll be handing those off. Thank you very much.